Hi, this is the third compound in the series. The name of the compound is saccharin. Now, for all those listeners who love eating sugar, then this is the compound for you. It's an artificial sweetener. So, if you love eating sweet things, then this is the thing for you. It is actually an artificial sweetener. That means it is not actually sugar, but it can sweeten your things. So it is practically used to sweet products such as drinks, candies, jellies, jam, other things, but it is not sugar. So this can be helpful for somebody who do not want to consume calories but want to eat sugary substances. And in fact, it is very sweet. You can see that it is roughly around 300 to 400 times sweeter as compared to the sucrose, but it is no sugar at all. If you use it in high concentration, it can leave bitter and metallic taste. So use it in a good concentrations to get the most out of it. Practically, it is used to sweeten products such as drinks, candies, cookies, medicines, and a lot more things. If you see the word saccharin, it has been derived from the word shakkar, which is a Sanskrit word itself. So I hope you do not find it difficult to memorize this word. This word itself has been taken from the Sanskrit word shakkar, that means sugar. And likewise, there are many words which have been derived from the Sanskrit language and were later on carried by the Latin language, then the Greek language and English language. And in fact, Hindi has its word derived from Sanskrit. So almost all the world major languages have derived their words from Sanskrit language. You can see some of the words which have been derived from the language Sanskrit, like the Sanskrit word Pitru become pater in Latin, became pater in Greek, and became father in English. Similarly, the word Bhrata becomes frater in Latin, frater in Greek, and brother in English. So you can see there are many words which have been, these are just some of the words which have been derived from the Sanskrit language. Now let us move on to the structure. So if you see the structure of saccharin, then it is benzene fused with a 5-membered ring. So the 5-membered ring contains sulfur on the first position, nitrogen on the second position, and on the third position it has a carbonyl. So if you pay attention to the IUPAC name, then this molecule is benzothiazole derivative. Benzo because there is a benzene ring inside it, thiazole because of three things. Thia means sulfur, aza means nitrogen, and ol means it is a 5-membered ring. So that is why it is thiazole. Now 1,1,3 trion, because on the first position there are two double bond oxygen and on the third position there is one. So 1,1,3 trion, and 2H because there is hydrogen on the second atom. So likewise the IUPAC names are designed. I hope if you are given the structure, you can recall what its IUPAC name should be. You can choose the correct option out of the 4 options given. This is how the questions are asked in competitive exams. It has some suitable properties, such as it is heat stable. So if you are going to heat this compound, it is going to be stable. It is not going to create some toxic substances when you heat it. Nothing is gonna happen like this. It is inert in nature, so it does not chemically react with other food ingredients. You are going to mix it with other compounds, so then that means it is going to be inert. No new chemical compounds are going to get formed. It has good solubility as its salt form, so it is converted to the sodium salt form, and then it is water soluble. So again, good property to be mixed into the food items. Now this can be prepared from the compound toluene. Toluene is nothing but benzene attached with methyl group. We are going to do sulfonation here. So instead of using H2SO4, we are using ClSO3H. So it simply has one hydrogen replaced with chlorine. So one hydrogen is going to get consumed and ClSO3 is going to get attached on the ortho position and the para position, because our methyl group is ortho and para directing. So that is why we are going to get two compounds. One is the ortho isomer and the other is the para isomer. And we are going to isolate the one compound out of the mixture, and we are going to selectively react ortho isomer with ammonia, and this is going to replace the chlorine with NS2. So this is how the compound formed is called sulfonamide, because there is sulfonyl group and there is amide, so the compound is sulfonamide derivative. Now we are going to oxidize this molecule. Oxidation can lead to conversion of CS3 to COOH. Now there are some oxidizing agents such as KMNO4, K2Cr2O7, which can oxidize the CS3 group into COOH, the carboxylic acid functionality. Once this carboxylic acid is formed, it can react with this amino group of sulfonamide to finally cyclize the ring. So this is how the final product of saccharin is synthesized. So I hope you have got this scheme right. So this is the synthesis of saccharin. Now let us go to the uses of saccharin. As I have already told you, it's a synthetic sugar. It's a artificial sugar which has 0 calories. So somebody who is diabetic or somebody who for weight loss reason do not want to consume calories, then this is the substitute which can be used. Now one another property is that human can't break saccharin. So this is good that it leaves our body unchanged, so it does not get deposited, it does not get consumed or anything like this. It simply leaves the body unchanged. It is roughly around 300 to 400 times sweeter as compared to regular sugar. So only a small amount is needed to get the sweet taste. Food manufacturers often use saccharin because it has good shelf life, so you can store this compound for a long time and still it is going to be safe to be consumed. It is practically used in drinks, in jams, jellies, candies and cookies, and in fact medicines. So it's a good compound. It is still being used till date. So very amazing compound. I hope we have covered every aspect of it from the exam point of view, theory exam point of view and the competitive exam point of view. So that's it for this video. In the next video we are going to cover the last topic, which is chloramine.